Good day, everyone. Good day, students. We are now in week 3 of the course, and we are still discussing the first chapter. But today we are now going to the next section, which is part 2 of the chapter, Introduction to DBMS. So now in this section, we will study more about the introduction of DBMS, which is including the part of schema, subschema, and instances. And then we are going to learn about the three level architecture of DBMS, includes the levels or view, and then the mapping, the advantages of the three-level architecture, data independence. And of course, we are moving on to the next part. It's called data models. So we are going to introduce what is the data models, and then the characteristic and the types of the data models. And let's see some of the record-based and object-based data models, and then object-oriented, semantic, and functional data models. And after that, we'll move to the discussion about the types of database system. And we will see some of the types according to the type of use and the site of locations. And at the end of the chapter, we will compare between the client server and the distributed database system. So let's just start it with the understanding schemas, subschemas, and instances. You need to know what is schema. So schema is like a blueprint for a database. I have told you about this at the class. So it outlines the structure of the database by defining its entities, the attributes, and the relationship. So let's think of it as a framework that tells you where and how the data should be organized without actually holding the data itself. So the key points of the schema is about the entities, the attributes, and the relationship. So the entities itself are the main object or the things that we store data, just like an item, a customer, or a sale. Meanwhile, for the attributes, it's more like details about these entities. For example, we have an item price and then a customer's name or the date of the sale. For the relationship, it shows how these entities are connected. So for examples, a customer might buy multiple items, so it creates a relationship between them, between the customers and the items. So about the static framework. So the schema itself doesn't change often. It stays the same even when the actual data within the database. So it's like a list of the customers or items which is changed frequently. So we have some types of the schema. The first one is called a logical schema. So it's more focused on the structure of the data, and it defines what a table exists, what the columns they have, and how they are related. So it's more like a design and organization of the database. The second type of the schema schema is called physical schema. So it deals with the how the data is stored and the physical hardware. It includes details about the file locations, indexing, and storage format. So for schema definition, we use some tools like DDL and DSDL. So DDL stands for Data Definition Language. So this set of command is used to create and to modify the structure of database objects like tables and indexes. Meanwhile, for the DSDL, which stands for Data Storage Description Language, this specifies how the data is stored in the database, which is focusing more on the physical storage details. So if I can give you an examples, maybe the simple one, yeah, for a store. Let's say I have the entities of item and then customers and sales. So I have item. I will just so let's say I have an entity of item and then customer and sales. Okay, so this is an item, customer and sales. Okay, the attributes of the items, the attributes for the items might have item ID, name, and price. Okay, this is for the items attributes. And then for the customers attributes, there might have customer ID and then name and then the address. Okay, and the entities of sales might include the sale ID, the date, item ID, and the customer ID. So the relationship of the cell will link between a customer and to item. The showing which customer bought which an item and when. So in summary, a schema is like a map, or we can say a plan, that helps to organize and define how data is stored and related in the database. It sometimes is staying consistent even as the data itself changes. Next is about subschema. So what is a subschema? So a subschema is like a focus snapshot of a larger database schema, and it shows only the parts of the database that are relevant to specific users or applications. Think of it as you personalize view into a database and tailor to what you need to see and what you need to use. So the key points of the subschema, or we can say subset of schema, it includes only certain part of the entire database schema. For examples, if the full schema includes detail about items, customers, and sales, a subschema may only show the sales information. Meanwhile, for the customer's views, it will allow different users or applications to see and interact with just the data they need. This will help in focusing on the relevant information without getting distracted by the unnecessary details. And each subschema can be modified independently. Changing one subschema doesn't affect the others, which is allowing for flexibility and customization without disrupting the overall database structure. So subschema using what is called SDL, yeah. So it's a set of commands used to define and to manage the subschema, where it specifies which part of the main subschema should be included in the each subschema. So imagine you have a large database for a store, which includes I can say items, customers, sales, suppliers, and inventory. So you might create different subschemas for different department. Let's say sales department subschema, which is only includes the sales and the customers data, and inventory department subschema, which only includes the items and the inventory data. So with subschemas, the cell teams only see the data relevant to the sales and customers. Meanwhile, the inventory team sees only the data relevant to items and stock levels. So each team gets a simplified view of the database that suits their specific needs. They offer some benefits. I can say like focus access, and which is related to the security and of course the flexibility. So in summary, a subschema provides a tailored view of the larger database schema, showing only the relevant parts for the specific users or applications. This makes the data management more efficient and secure. Instances. So what is an instance? An instance is the context of the database refers to a specific snapshot of the database at a particular point in time. So it shows the actual data value stored in the database at the moment. So some key points about the instances is the first one is called snapshot of the data. So an instance captures the current state of the database, which includes all the data entries present at the specific moment. It also support what is called dynamic nature. So the instances change whenever the data in the database is updated. And this can happen through the various operations like adding new data or intersection, and then removing data, or we can deletion, or changing existing data or modification. And the instances can give any multiple instances. So for any given database schema or the blueprint of the structure, there can be many instances over time. Each instance represents the database state at a different moment. For an example, I can give you a database with a schema that defines a table for an items in store. Yeah, for examples, we have a name, table name, item, and with the columns of item ID, name, and then price. At different times, the actual data of the item table may look like the item ID with the value of 1, and then the item name apple, which price 1. And the second item ID is 2, name banana with the price of 0.5. So after adding the new items and updating a price, there will be uh, different value for each field. And each of these is different instances of the same schema. And the schema remains the same. It still defines the item table with item ID, name, and price, but the instances show different data values at a different time. So in summary, an instance is a current snapshot of the database schema, which is displaying the actual data values at a specific point in time. And the instances changes as the data is updated, and the multiple instances can exist over time for the same schema. Let's move to the next section, which is called tree-level architecture in DBMS. So this is the picture of the tree-level architecture in DBMS, and they are grouped by levels and mapping. Yeah, we have external view 1, external view 2, external view N, and some of the mapping conceptual level and internal level. We will check one by one, okay? We will discuss one by one. So in database architecture, there are different levels of abstractions to manage and access data efficiently. And one of these levels is the internal levels. So what is the internal levels? The internal levels, also known as the physical level, is the lowest level of the database abstraction, and it focuses on how the data is physically stored in the database system. So the internal level deals with the actual storage of data on the hardware. It involves the coding schemes and determine how the data is stored and retrieved efficiently. And this level handles the allocation of the storage space for the data, and it defines how much space is needed for the data storage and where the data is stored physically on the storage medium. It defines the path for accessing data, which includes the indexing and other methods that speed up the data retrieval. And data may be compressed to save space and encrypted to ensure the security at this level. And this process helps in managing storage efficiently and protecting data from the unauthorized access. Unlike the higher levels that use tabular form, the internal level deals with low-level data structures. For examples like B trees, hash tables, and file organizations. For example, sequential, heap, and cluster. And the internal schema defines how the data is stored in the database, including details about storage space allocation, the record placement, and the data structure used. So consider a database storing information about books. In the high levels, or we can say conceptual and external, you can see it in a tabular forms like a table with columns, for a book ID and then title, the author, and the price. Meanwhile, for the internal levels, the database might use a B3 index to speed up the searches. And the data compression might be used to store the text of the book's titles and the authors more efficiently. And the data encryptions might protect sensitive information like pricing. Meanwhile, the storage allocation will ensure that enough space is available for the new books and the records are placed efficiently on disk to minimize retrieval time. So in summary, the internal level of the database will focuses on the physical aspect for the data storage, which includes the storage allocations and then the access path, the data compressions, and the encryption. It deals with the data structures and file organizations at the low level, ensuring the efficient and secure data management. The next level of the database views is called conceptual level. So what is conceptual level? The conceptual level of the database describes its logical structure without focusing on how the data is physically stored, and it provides a high-level view of the entire database, showing the relationship between the different data elements and the constraints that might be applied to them. So at the conceptual level, the database is described using a relational tables and the operations. It focuses on how the data is organized logically, not how is it physically stored on the disk. This level abstracts away the details of the physical storage. Users and developers see a clean, logical representations of data without worrying about how is it actually stored or managed in the system. And the conceptual level is defined by the conceptual schema, which provides a detailed map of the entire database. This schema includes all entities, attributes, and relationships, along with the integrity constraint. The conceptual level is also known as the logical level, so it represents the overall structure of the database, showing how the different parts of the data are related. As the examples, let's imagine a database for a library. So we have an entities of books, authors, and borrowers. With the attributes for books, we have book ID, title, genre, and then for the authors, we have author's ID and name. For the borrower's ID and name. And then the relationship. Each book can be written by multiple authors, and each borrowers can borrow multiple books. So at the conceptual levels, you will see a table for books with columns for book ID, title, and genre, and a table for the authors with columns for author's ID and name, and then a table for the borrowers with columns for borrower's ID and name. Meanwhile, the relationship indicates that the books are borrowed by which borrower. You won't see any details about how these tables are stored on disk, how the indexes are managed, or how the data is physically partitioned. Those data are part of the physical levels, not for the conceptual level. So in summary, the conceptual level describes the logical structure of the database using relational tables and the operators, and it also abstracts the physical storage detail, focusing on the overall organizations and relationship of the data as defined by the conceptual schema. The next levels, based on levels or view, is called external levels. So the external levels of the database is concerned with how the individual users view the data in the DBMS. These levels is tailored to provide the users with a personalized view of the database that suits their specific needs and permissions. The external level presents a customized view of the database for its users, and this ensures that users only see the data relevant to their roles and responsibilities. These customers' views are defined by external schemas, which are set by the DBA, or we call it Database Administrator. So the external schemas control what each users can access to ensure that sensitive data is protected and that users only see what they are authorized to see. By setting external schemas, the DBA can enforce access control, making sure that users cannot view or manipulate data they shouldn't have access to. This is crucial for maintaining data security and integrity. And the external level is designed for direct interaction with the the users. It typically presents data in a way that closely resembles the relational models, tables, rows, and columns, making it intuitive and easy to use. Each user or user group can have a unique view of the database that fits their specific needs. For example, an employee in the sales department might see sales data, while someone in the inventory department sees the inventory data. So, as the examples, consider a database for a retail store. The full database contains of tables for customers, product and sales, and inventory. And different users might need to see different parts of this database. Yeah. So, for example, if we have a salesperson view, they only can see sales and customers. Yeah. The salesperson can view and update sales records, view the customer information. And meanwhile, for the inventory management manager's view, they can view and update products and inventory levels. For the customer service representative, they can view customer information and sales history, but they cannot update sales records. So DBA sets up the external schemas for each of these roles to ensure that they have access only to the data they need. So in summary, the external levels of a database provides tailored views for individual users defined by the external schemas to ensure data access control, and this level enhances the security, simplicity, and efficiency by allowing the users to interact with only the data they need. Now let's move on to the next type based on mapping. So conceptual or internal mapping is in a database system plays a crucial role in how the data is handled and represented. So what is conceptual or internal mapping. So it's the process of translates data from the way it is physically stored in the database to the way it is logically organized and presented at a higher level. This mapping ensures that the users can interact with data at a conceptual level without worrying about how is it physically stored. And this mapping defines how the data is fetched from physically storage. So it's just like the hard drives, and how is it represented at the conceptual level. So it's just like a tables and records, and it acts as a bridge between the physical storage and the logical organizations of data. It helps in resolving any differences in entity names, attribute names, and data types. So, for examples, it ensures that a field name's customer ID in the physical storage is mapped correctly to customer ID at the conceptual level. One of the main goals is to achieve physical data independence. This means that changes in the physical storage, like how data is stored on the disk, do not affect the conceptual view of the data. Users and applications can still access and manipulate data without being impacted by the physical storage changes. This mapping information is stored in the DBMS catalog, and the catalog contains metadata that helps the system to manage and use the data efficiently. So imagine a database for a library where the data is stored in a binary files on the disk. It's physical storage, and then the conceptual level, which is data is represented as tables with rows and columns, just like books table with columns for book ID, title, author, and genre. So the conceptual or internal mapping will ensure that when you query the books table for all books by a certain author, the DBMS knows how to retrieve this data from the binary files and present it as rows and columns in the table. So, in summary, the conceptual or internal mapping is the process that connects the physical storage of data to its logical representation at the conceptual level. It also ensures that users can work with data easily and that changes in physical storage do not affect how the data is accessed and used. And this mapping is stored in the DBMS catalog, ensuring efficient and smooth database operation. The next, based on a mapping, is called the conceptual or external level mapping. This specifies how the data from the database conceptual view, which is logical organizations of data, is presented to different users, and it involves defining how the data is displayed and interacted with at the user level. So the data field names and schema details is allows for customizations of data field names and schema details to match the needs or preferences of individual users. For instance, the same data can be presented with different names or format depending on the user's role or requirement. And in terms of multiple mapping, you can create multiple external views for different users or groups. And this means different users can see and interact with the data in ways that are most relevant to them without changing the underlying database structure. And talking about the logical data independence, by defining external views, the changes to the conceptual schema, or we can say the underlying structure of the data, do not affect how the data is presented to the user. And this helps in maintaining a separation between the data's logical organization and its preparation, providing further flexibility and stability in the data management. This approach is crucial for ensuring the users can interact with the database in ways that are most useful to them while preserving the integrity and the structure of the data. Let's move on to the next level of architecture. It's called the tree-level architecture. So it's a way to design databases that separate different aspects of the systems to make it more flexible and easier to manage. In terms of the user independence, each user has their own unique view of data, and these views are separate from the actual physical storage. This means the users only see the data they need and don't have to worry about where and how is it stored. So different users can have customized views of the same data. For example, an employee in the sales department might see sales data, while an employee in the human resource department sees employee data, and both are looking at the same database but seeing different parts of it. If the physical storage of the database changes, like moving data to a new server, it doesn't affect the internal structure of the database. And the way the data is organized and accessed stays the same, which simplifies the maintenance. It also have the what is called the DBA flexibility. So the database administrators or DBA can change the database structures, like adding new tables or changing data format without affecting the user's views. And this allows for improvements and optimizations without disrupting the users. So in summary, the tree-level architecture makes databases more flexible, easier to manage, and more user-friendly by separating user views from physical storage and allowing independent modification. Let's talking about the some terms in DBMS. Data independence. So data independence means that you can change one part of the database without having to change the other part. This is very important because it makes the database easier to manage and to maintain. There are two types of data independence. We'll typically talk about it in the next slides. The first one is called physical data independence. So physical data independence is where you can change how the data is stored physically without changing how the users use to see the data. And why is it useful? If you need to move data to a new type of storage, just like from one server to another, you do need to update the applications that use the database. The next type of data independence is called logical data independence. So, logical data independence is where you can change the structure of the database, like adding new fields or tables without affecting how the users interact with the data. And why is it useful? If you need to update a database to include more information, you can do this without changing the existing applications that depend on the database. So, what are the benefits of data independence? We're talking about the flexibility. It allows you to update and improve the database without disrupting the users or applications that depends on it. Also, ease of the maintenance. It simplifies the process of making changes to database, whether those changes are physical, it's storage related, or it's logical, it's structure related. So how it works, how the uh, how the data independence work. In this tree-level architecture, this architecture separates the data into three level. Yeah, like I said, the physical level, conceptual level, and external level. So when we're talking about the physical level, is how the data is actually stored. And we're talking about the conceptual level, where the logical structure of the database. And if we're talking about the external level, is how the individual users see the data. Okay, let's start with the physical data independence. So the physical data independence is a concept in database management that allows the changes to the way data is physically stored without affecting how the data is viewed or accessed by the users. And what is exactly means? So you can change the physical storage structure or devices, like moving from one type of storage device to another, but without changing how the data appears to the user. And how it works. The database has different levels, as you know. The internal levels is the physical storage, and then the conceptual is the logical structure, and the external or the user views. The changes in the physical storage only affect the internal levels, but not in the conceptual or external levels. What is the benefit of physical data independence? We're talking about the adaptability. So you can upgrade or change storage hardware or technique without needing to rewrite applications program or change how the users interact with the data. Also, it supports the sustainability. So database remains stable and consistent for users, even as technology changes. And the other benefits is the robustness. The system can evolve with the storage method without disrupting users or their applications. Imagine you have a library database. If you move data from old hard drives to new solid state drives or SSD for faster performance, the users or the, let's say, the librarians or the readers will see uh, the same catalog or the data as before. It's only the internal storage changes, not the way the data is accessed or viewed. So in summary, we can conclude that the physical data independence is allowing changes for the storage mechanism without affecting how the users see or interact with the data, and ensuring the flexibility and robustness and of course the ease of maintenance in database system. Next one is the logical data independence. So the logical data independence is a concept in database management that allows the changes to the logical structure of the database without affecting how the data is accessed by the users or applications program. So what it is exactly means? So you can change the conceptual schema, or we can say the logical structure of the database without changing the external schemas or how the users and applications see the data. How it actually works. So the database has different levels. Is the external levels, user views, and then the conceptual levels or the logical structure, and the internal level, or we call it physical storage. The changes in the conceptual schema only affect the mapping between the external and the conceptual levels, not the external views themselves. So, what are the benefits of the logical data independence? We're talking about the flexibility, adaptability, and efficiency. So it's flexible. You can make changes to the database structure, or such as adding new fields or tables without requiring changes to user interfaces or application programs. It is also adaptability, so the database can evolve to meet new requirements without disrupting existing applications. It also efficient at the same time, which is makes it easier to manage and update a database as changes can be made to the logical structure without affecting how the data is accessed externally. And imagine a student database where you want to add a new field for student email addresses. With logical data independence, you can add this field to the conceptual schema without needing to change how the current applications access the student names and grades. So the users and the applications will still interact with the data in the same way as before without needing any modifications. So in summary, we can say that logical data independence allow changes to the logical structure of the database without affecting user views or application programs, and ensuring flexibility, efficiency, and ease of maintenance in database system. So let's move on to the data models. We will understand more what is data models and what are the characteristics of the data models. So a data model is a framework used to describe and organize the data within a database. It's more like a collection of concepts that describe the structure of the database. It includes the details about data types, relationship between data, and the constraints on the data. And the components of the data models is include the data types. Yeah, it's the defines the kind of data. For example, is it integers? Is it strings, state? Yeah, something like that. And then it also includes the relationship, which is describe how different pieces of data relate to each other. And then it also includes constraints. So it's a rules that ensures the data integrity. Yeah, for example, a student age must be a positive number. You cannot say minus 17, right? Your age is 17, so it should be a positive number. So what are the benefit of of the data models? We are talking about understanding the data requirement. So it helps to identify what data is needed for each users and how it should be used across the different applications. It also supports what is called independence from the physical storage. And it's more focused on the logical structure of the data without concern for how is it physically stored. If we are talking about the communication between the users and the designers, it provides a common language for the users and database designers to discuss and to understand the data requirements. It also ensures that everyone involved has a clear and consistent understanding of the data and its organization. Think of a data model as a blueprint for a house. It shows where each room is, the size of the room, and how they connect. So it's similarly like a data model shows the structure of the data and then the type of the data and how they relate to each other. So in summary, a data model serves as a crucial tool in the database design and helping to define the structure, the relationship, and the constraints of the data. It also aids in understanding users' data requirements to support the effective communication between users and designers and maintains focus on the logical organizations of data, independence of its physical representation. So a good data model should have the following characteristic to ensure the optimal data representation. The first one we call it diagrammatic representation. So the data model should use pictures or block diagrams to show the how the data is organized. And it's also simplicity in design. The data and how they relate to each other should be easy to understand to and identify. Next one is the application independence. So the data model should be designed in a way that allows different programs or applications to use it without needing major changes. No duplication. So each piece of data should only be represented on once in the model to avoid redundancy. Bottom-up approach. The data model should be built starting with the most basic data and gradually adding more details. And of course, the consistency and structure validation. So the model should always be logical and well organized. And there should be ways to check that it stays correct and structured properly. Now let's check the type of data models. First one is called record-based data models, object-based data models, and last one is physical data models. We will break down them one by one in the next slide. In terms of record-based data models, it's divided into three types. It's the hierarchical data models, the network data models, and the relational data models. So as you can see in the picture, as you can see in the slides that you can read by yourself the difference between these three. That the hierarchical data models, it's organizes data in the tree structure with a parent-child relationship. Meanwhile, for the network data models, is a more like a child for having a multiple parents. And the last one, we'll talk about the relational data models. So we're talking about the data which is represents in the form of tables with with rows and columns. Yeah, the rows is the tuples and the columns in the attributes. For the clear understanding about these data models, we just skip to the next slides. So based on the previous description, please identify the following data models. We have three types as explained in the previous slides. It's the hierarchical data models, network data models, and relational data models. So which one do you think is the hierarchical data models? And which one is the network data models? And which one is the relational data models? Which one? Let's see the first picture, okay? So the first picture, it contains nodes which are connected by branches. At the topmost of the topmost of the node is called the root nodes, and each node has exactly one parent. And one parent may have many child. So one parent may have many childs. Meanwhile, the child only have one parent. Okay, as you can see here. So we can conclude that the first picture is the hierarchical data models. Okay. Yeah, so it's the hierarchical data models. Move on to the second pictures. So the second pictures is the contradictory with the first one. So for the second one, we can see that the node A has children of node C, D, E, and F. Okay. Meanwhile, node B has children and C, D, E, and F. So we can conclude that the node C, D, E, and F has two parents, right? So in this case, the picture 2 is the network data model. So can you identify the third picture? What is the data models? Yeah, it's the relational data models because it represents the data in tables. We have tables and rows and the attributes kind of things. So it's called the relational data model. So that was the record-based data models. Now we move to the next type based on the object data models. So The object-based data models this consists of four types, as we can see in the slides. The first one is entity relationship models, and then the object-oriented model, semantic data, and functional data models. Let's check one by one and see what is the difference between these four. So the first type is the entity relationship models and the object-oriented models. So the entity relationship models uses the ER diagrams to represent elements of the conceptual models. Meanwhile, for the object-oriented models, is using the object captures semantic of the objects as in the object-oriented programming. The semantic data models is more like a conceptual diagram of the data as it related to the real world. Meanwhile, for the functional data model, it describes system aspects related to value transformations, mapping the constraints, and the dependencies. Let's check what the examples of the object-based data models. Based on description which is had, which data model is this picture? So as we can see here in the picture, we are seeing an entities and a relationship. So entities and relationships. So this one is called, yeah, entity relational models. Yeah. So this one is called DR model, entity relationship model. Let's move to the next examples. How about this picture? As we can see in the picture, we can see the following things. The first one is the object. So an object is an abstraction of the real world entity, or we can say it as an instance of the class. The object encapsulated data encoded into single unit which provide data abstractions by hiding the implementation details from the users. So as we can see here, the instances of the student, the doctor, and the engineer in the picture. The next one we can see in attributes. And attributes describe the properties of the object. For example, object is the student and its attributes are the roll number, the branch, set marks, is in the student class. We also see what is called method. So method represents the behavior of an object. So basically it represent the real world action. For examples, finding a student's mark in the figure as set marks. Next one, we can see a class. So a class is a collection of similar objects with shared structure. For example, attributes and behavior, and for example, methods. An object is an instances of class, for example, person, student, doctor, engineer in the figure. So can you mention what kind of uh data model is this? Yep, it's the object-oriented models. Okay, let's move on to the next one. So what kind of data model is this? Let's see, we have an artist as the core element, which is represents a musical artist or groups. And then there is an album represent a collections of musical recordings by an artist. And we can see a journey, an example of an artist, in this case a musical group. Raised on radio, an example of an album, yeah, presumable by the artist of Journey. And records is the label indicating that Journey is the artist associated with the raised on radio album. So we can see a relationship here. Yeah, the relationship here is N, which is linked between the general categories, artist and album. Okay, and there are specific instances, Journey and raised on radio. This signifies that Journey is a type of artist and raised on radio is a type of album. So these semantic models established by a basic structure for representing information about artists and their album. So it allows you to categorize and link specific entities like Journey and raised on radio within the broader concept of artist and album. So can you guess what kind of data model is this? Yeah, it's an asemantic data models. Let's move on to the next type of data models. Yeah, so because it's the only one, so you can see that this is a functional data models. Okay, so the core, what is it called functional data models? We have core components like entities. So we have a student, we have a faculty, we have admin and university management systems. So these four are the entities. And then the processes. So we have login and register, course registration, add course here, and then few mark sheet. And we can see cancel and login and register, and then response. Okay, and the data flows, yeah, it's connected by the arrows right here, which is connecting the entities, and the process indicate the flow of the informations or the actions. So if we want to look into this picture, we know that the functionality from the student can log in and or register to access the university management system, and once logged in they can view their mark sheet. Yeah, they can view their mark sheet, and then they can register for courses, right? And then and potentially cancel their registration. Okay, cancel. Meanwhile, for the faculty interactions, the faculty members can log in and register to access the university management system, and their primary function is to mark students' attendance. Okay. Meanwhile, for the admin interaction, the administrator can log in or register to access the university management system, and then they have the authority to add new courses, yeah, to add courses to the system. And the last entities, which is called university management system, is the central hub that handles all the interactions and the process. So it processes login and registration requests, course registration, and then mark sheet view, attendance marking, and I can course addition, mark sheet view, attendance making, cancellation request, and it generates responses to the user action. So how to choose the data models? Choosing a data models for a database involves considering various aspects. The first one is the size of the database. You need to know how much the data will be stored, and then a cost involved, the expenses related to using and maintaining the database, and how many operations, like the volume of the daily transactions, like adding, updating, or deleting data, which happened each day. And then you need to know the number of queries made, so how often the data is accessed or the search. Different types of data models have the ways to structure the database are better for different situations. So the base data model for you will depend on your specific needs and limits. Next, let's move to the next section. It's about the types of database system. So according to number of users, the database system can be further subdivided into two categories. The first one is called single user database system and multi-user database system. The main difference between single user database system and multi-user database system lies on how many users can access and interact with the database concurrently. So here are the key distinctions between these two. For the single user database system, the access is designed for one user at a time. Meanwhile, it's no concurrent access. Only one user can interact with the database at any given time, and generally simpler in design and implementation since they do not need to handle multiple users. It can be optimized for a single user, often resulting in faster performance for that user. It's suitable for desktop applications, personal data management, or environments where only one person needs access to the database at a time. Meanwhile, for the multi-user database system, the access of the multi-user database system is designed for multiple users to access simultaneously, and it handles multiple users concurrently, managing conflicts and ensuring data consistency. It is more complex, requiring mechanism for concurrent control, locking, and transaction management to prevent issues like data corruption. And it also needs the balanced performance across the multiple users, which can be challenging, especially with the high numbers of the concurrent users. It is suitable for enterprise applications, web applications, and any environment where the multiple people need to access and interact with the database at the same time. So, we can conclude that the key difference in functionality is related to the control, where the multi-user systems require sophisticated concurrency control mechanism, for example, like locking, timestamps, which is to manage the simultaneous access and ensure the data integrity, whereas the single user system do not. Talking about the transaction management, the multi-user system must support the transaction that ensures the SCID properties. So SCID properties is atomicity, consistency, and then isolation, durability, even when the multiple transactions occur concurrently. It is also connected to the security and permissions. When the multi-user systems often include more advanced security features, such as the user's roles and permissions, to manage different levels of access among the users. And here's the examples of the database type based on the number of users. Single users and multiple users, as you can see in the slide. And according to the type of use, the database system can be subdivided into three categories. It's production or transactional database system, decision support database system, and data warehouses. Let's break them down. So the production or transactional database system used to manage things like supply chain, production of items in factories, inventory in warehouses or stores, and orders for items. And the transactional database will handle things like credit card purchases and generating monthly statements. They are also used in banks for customer information, accounts, loans, and other banking transactions. For the decision support database system, it helps the users to make decisions where there are computer systems that store and retrieve the data and help with building models and solving the problems. These systems are used in areas like business management, healthcare, and then the military, where the complex decisions need to be made. And they are used mainly by the upper level management for strategic and tactical decisions, which are important but not made very often. And this database stores large amounts of data related to the problems the system is designed to help with and provides a way for users to interact with data. Meanwhile, for the data warehouses, it's a type of database system designed to handle the large amount of data from transactions processing system. It can be thought of as a centralized storage place where data is kept and can be accessed for the business purposes. According to the database site locations, database system can be further subdivided into four categories, namely centralized database system, parallel database system, distributed database system, and client or server database system. Let's break them down one by one. For the centralized database system, has a single processor with data storage devices and the other peripherals. The database files are stored or either personal computers, just in case for the small businesses, or a mainframe computer for large businesses, and applications run on this same PC or mainframe. The multiple users access these applications through the simple terminals, which do not have their own processing power. The user's interface is text-based and business rules are enforced by the applications running on the mainframe or the PC. An example is the DB2 database and COBOL application program running on an IBM 390 mainframe. The advantages of the centralized database system is talking about the excellent control and the security. So the centralized systems provide excellent control over the applications and the security. It also low incremental cost because it adding more users is inexpensive. It also high reliability. So these systems are highly reliable due to proven mainframe technology. And of course, it ease of management. Functions like querying, pickup, and updates are easier to manage. Meanwhile, for the disadvantages of the centralized database systems is the limited data manipulation. So users cannot easily manipulate data outside of the standard applications. It also poor advanced interfaces. The system just does not support advanced user interfaces well. And its single point of failure, meaning if the central computer fails, all the users are blocked from using the systems until it is restored. And it's also high communication cost. So the communication from the terminal to the central computer can be very expensive. The next one is the parallel database system. So the parallel database system uses multiple processors to work together, either in a tightly coupled or loosely coupled way. These systems link several smaller machines to achieve the same performance as a single larger machine, often with better scalability and reliability. Parallel database systems are ideal for applications that need to query very large databases or process a very high number of transactions per second. There are three main types of parallel database architecture. It's shared memory architecture, shared disk architecture, and shared nothing architecture. And the advantages of the parallel database systems, it can handle a large database. Yeah, so it's ideal for applications requiring queries on large databases or processing many transactions per second. It also high response time. So it has a quick responses to queries and transactions. High throughput. Yeah, so it can handle many transactions or queries simultaneously. High response, no, sorry, high I/O and processing speed. Fast input output, yeah, and processing capabilities. Scalability and reliability. It better scalability and reliability compared to the single processor system. So how about the disadvantages of the parallel database system? For the startup cost and time. So initial cost and time to set up can reduce the overall speed. And it's about the resource competition. As more processes run in the parallel, they compete for resources, which can slow down the performance. And the following is the architecture of the centralized database system. The next one is the distributed database system. So, a distributed database system has data spread across the multiple databases managed by different database management systems running on various types of machines with different operating systems. These machines are connected through the communication networks and able to act as both servers and clients. This means each machines can have its own data and applications and also access data on the other machines. A distributed database system combines logically connected databases distributed over a computer network with a distributed database management system, and it can be either homogeneous, where the same DBMS and platforms, or heterogeneous, different DBMS and platform. And what are the advantages of the distributed database system? It's improved the sharing, so it's better ability to share the data. Local autonomous. Each site can manage its own data independently. And the availability, the data is more available since it's distributed. And reliability, more reliable because it's less likely for all sites to fail simultaneously. Improve performance can improve the performance by distributing the workload, and it's easier expansion because by adding more machines and reduce the communications overhead, economical and direct user interactions, no single point of failure, and processor independence. Meanwhile, for the disadvantages of distributed database system is talking about the architecture complexity, the lack of standards, lack of professional support, and data integrity problems, security issues, and then the high cost and complex database design. For the client server database system, with the technology becoming cheaper and more personal computers being used, the enterprises started using client server technology instead of centralized system. In the client server technology, there is a server that acts as the database management system and clients, the personal computers connected to the server through a network. So the components of the client server architecture is includes the server, the client's network interfaces. In client server architecture, there can be multiple servers, and each serving different functions, such as the database server, application server, or backup server. And the advantages of the client server database system is the improved performance of the DBMS. And then when we are talking about the load distribution, it distributes the load among the clients. Also has the better user interface, so it's provide a better user interface and complex applications cross platform where the clients with different operating systems can connect to each other and share the DBMS. A single copy of the DBMS is shared, and of course the cost effective because it can reduce the cost. Talking about the disadvantages of the client server database system It's related to the network issues and then centralized risk, recovery challenges, hyper programming cost, and the complex implementation. And here's the examples, and here is the architecture of the distributed database system and client server database system. Let's move on to the next sections, which is about the comparison between the client server and distributed database system. Okay, so let's break down the table comparing client server database system and distributed database system. Talking about the platform management, the client server managing the different platforms like the hardware and software, it's more challenging. Meanwhile, for the distributed, it handling diverse platforms across the multiple locations is easier. The next differentiation is about the application distribution. For the client server, applications are often distributed across the individual client machine, while the distributed applications are spread across different sites within the system. Talking about the system failure, the client server, if the server crashes, the entire database system becomes inaccessible. Meanwhile, for the distributed, the system is more resilient to failures. If one site goes down, other sites can continue operating and maybe be able to request from the failed site. For the maintenance cost, the client server generate lower maintenance costs due to the simple infrastructure. Meanwhile, for the distributed, it's higher maintenance costs associated with managing multiple sites and network infrastructure. And talking about the data access control for the client server, controlling data access is relatively straightforward within a centralized system, while for distributed database system, it managing data access and replication across multiple locations requires robust security measures and control mechanisms. When adding to new sites, client server incorporating new sites into the system can be complex and disruptive. Meanwhile, for the distributed, adding the new sites is generally easier due to the distributed nature to the system. And the last differentiation is between the is about the database access speed. So for client and server, database access speed is typically good with a centralized server. Meanwhile, for the distributed database system, the access speed can be significantly faster due to data being distributed closer to the users. So we can conclude that distributed database systems offer advantages in terms of scalability, fault tolerance, and performance. But they also come with an increased complexity and management overhead. Meanwhile, for the client server systems, it's more simple. Yeah, it's simpler to manage, but may have some limitations in terms of the scalability, and availability. Okay, that's all of the material explanations for today, and I will see you in the next chapter, which is chapter 2. And good day, everyone. I'll see you next week. Bye bye.